Welcome, my friends, to the show that never ends. Come inside, come inside. All right, so we're at video 2 of Economics Flipped. Topic is choice. All right, we're going to look at it individually first, right? So we're going to look at the individual economy problem. Then we're going to look at it with money. Then we're going to look at it with just resources. Okay, so let's go through this. When we're looking at an individual economizing problem, we're going to have a limited income. So the income is going to be fixed, right? We're going to have unlimited wants. We're going to want as much of the products as we can have, right? We're going to have a budget line, and then we're going to have, there will be attainable and unattainable options on this, in this problem. And there'll be trade-offs and opportunity costs. Okay, and then what you want to do is make the best choice possible. So let's get to it. Change in income. So we're going to hold the income fixed, and then we're going to change it and see what happens. Okay, so let's look at it. We have an $18 budget, and we have two products, pizza and brownies, right? So we have pizza for $3 a slice, and brownies are $1. Now, we have a couple of different options here. If we want to spend all our money on pizza, we can get 6 slices, but we'll have no brownies. If we want to just have all brownies, we can get 18 brownies, no pizza. But let's say we really like pizza, but a little dessert afterwards would be nice. We could give up a slice of pizza and get 3 brownies. So we could have 5 slices of pizza and 3 brownies, right? But I like pizza, but I really like brownies too. So maybe I give up another slice of pizza, and I go 4 slices, and then I have 6 brownies. And I can continue to do that. But what we notice is every time we give up a slice of pizza, we gain 3 brownies, right? So 1 slice of pizza costs 3 brownies, right? If I have 0 slice of pizza and 18 brownies and I want to have a slice of pizza, it's going to cost me 3 brownies. And knowing that, then all I have to do is flip the equation, and I can get that 1 brownie, right? A brownie cost 1/3 of a slice of pizza. So let's look at that. Right, here's my 1 slice of pizza cost me 3 brownies. And my 1 brownie will get me 1/3 of a slice of pizza. All right, so we've gone through that. I would say graph this now. Take a moment, pause the video, right? Go back to the video, get the numbers. Maybe we're going to put brownies on the x-axis and pizza on the y-axis, right? So we're going to have 6 slices of pizza, no brownies, 18 brownies, no pizza, and we're going to connect those points also, okay? And when we look at it, this is what it looks like. Okay, it's a straight line because the cost is the same. The slope of the line is equal, right? 1 brownie or 1 slice of pizza costs 3 brownies, right? And you can see that we have the 2 points, 18 and 0 and 6 and 0. Right? Anything, we can have 4 slices of pizza, right? Or what could we do? We could do 2 slices of pizza, which is $6, and we could have 2 brownies, which is 2. We have $8. We could be inside the point, right? But what the concept is, we want to spend all of the money. So we want to be on the budget line. On the budget lines means we're spending all of the money. Underneath the budget line is an attainable point, but just not really good because we're being inefficient. And out to the right of the blue line is unattainable, right? We would love to have more of both, but we can't. All right, so that's the individual. Now what we want to do is we want to take that concept and we want to bring it over to the economy as a whole. Okay, first thing we want to look at is what are the 4 factors of production? So they are land. Land is also known as a natural resource. Anything that comes from the earth, right? Oil, coal, water. All of those are resources of land, right? Those, if it's easier, just call it natural resources, right? Next factor is labor, right? Labor is the workers that go into producing a good. So let's just throw this out there real quick. We'll look at Starbucks making coffee. What's the natural resource? Water and coffee beans, right? Then we have a barista making it. Well, what are we making it with? We're making it with capital, which is the machinery, the tools that go into producing consumer goods and services. Do not confuse capital and economics with money. If we're talking money, we'll say financial capital. In economics, capital is the tools that go into producing goods and services. Okay? So those are the three factors of production. Then we bring in the entrepreneurial ability. We take the guy, the Bill Gates, the Jeff Bezos, the Steve Jobs, those guys who make the decisions, the innovators, they take the risk. They take the land, the labor, the capital together, and they come up with a product. Right? That's what they did. I mean, look at, there's that whole thing with the Sopranos and the Italians going, man, we did this coffee before. We never realized this whole thing, right? But somebody at Starbucks said, wait a minute. We can make money. We can charge ridiculous prices for coffee, right? And then we just take the coffee beans, we get a couple of workers, some machines, and we'll run crazy with it. Okay, so those are your 4 factors of production. We're going to now use those 4 factors of production. We're going to look at what's called a production possibility curve, also known in some circles as a production possibility frontier, a PPF. Okay, I don't use a PPF. I don't call it a PPF. You can, it doesn't matter, right? You may see it when you're studying, if you study, a PPF instead of a PPC. Same thing, doesn't matter. Okay? Production possibility curve is a graphical representation of 2 goods. All right? There's scarcity involved, right? So there's going to be trade-offs and choice. Each point on the curve is the maximum. So on a production possibility curve, any point on the curve is the same as any other point. Okay? So if I move along the curve, all I'm doing is trading one for the other. I'm not worse off or I'm better off. I'm still equal. Okay, so what I like to do with the PPC curve, we'll do a worksheet together in class on this, but what I like to do is kind of get you understanding it. So what I do is I make up some assumptions for the production possibility curve, and instead of doing 2 goods, I do 2 sports. So let's look at this. Okay, some of the assumptions we're going to make when we're constructing a production possibility curve. Full employment. 96% of the labor force is working. Okay, why is it 96? We'll talk about that another time. Just know there's full employment when we're doing the production possibility curve. Our resources are fixed. Land, labor, capital, entrepreneur are fixed. We can't change those. Our technology is fixed. The coffee machine makes it the way it makes it, right? Okay. So let's look at soccer and field hockey. We're going to construct the PPC table, and then we're going to graph it. All right? First, we're going to have to ask some basic questions. Well, assumptions. The best athlete in soccer will be able to play field hockey, and the best field hockey player will be able to play soccer. Right? We're talking about the best athlete is usually pretty good in multiple sports. The skills are somewhat interchangeable. Right? Soccer, we're running around kicking the ball with our foot. In field hockey, we're running around using a stick. You know what? If I have the endurance and I'm fast, I can learn to pick up both sports. We're going to take 3 soccer players, okay, because I don't really know any field hockey players. And now there's some girls in the class right now giving me this dirty look because they are field hockey players. Sorry. So we're going to take the 3 soccer players. We're going to take Emma, Val, and Viv, right? Now, the assumption is Emma scores 40 soccer goals. Viv scores 20 soccer goals. Val scores 8 soccer goals. Now let's assume that you know who Val is, right? And you're going to call Val now and say, oh, Mooney Hadrian is an example, and he only scored 8 soccer goals, but Emma scored 40. Right, Emma's a forward, Vivian's a forward, Val's a defenseman. That's why she only scores 8 goals. Don't cause any trouble here. Okay, now, what season is hockey and field goal and soccer and field hockey played in? They're both played in the fall. So what's the cost of playing soccer? Field hockey. And what's the cost of playing field hockey? Soccer. You can't do both. You have to make a choice. Okay, so now we have this graph. And this graph shows that with Val, Emma, and Viv playing soccer, they get 68 goals. But none of them are playing field hockey. So there's 0 goals for field hockey. But if I take Emma and I move her to field hockey, I lose 40 soccer goals, so now I'm at point B, and I have 28 soccer goals. 20 from Viv, 8 from Val. But she's pretty good at field hockey, so she picks up 20 field hockey goals. Okay? What you notice is one field hockey goal is costing 2 soccer goals. So when we took Emma away, Emma's 40 soccer goals only produced 20 hockey goals. So it's costing 2 soccer goals for every field hockey, right? And then we think this is such a great idea. Why have we not done this before? Let's move Viv over to field hockey, and Viv gives up 20 of the soccer goals, but only picks up 5 field hockey goals. All right. So the cost now is going up. It's now 4-1, and then we move Val's 8, and we get 1, and now the cost is 8 soccer goals for 1 field hockey goal. All right, now we're going to plot it. So we graph it here, and you can see A, B, and C are the 3 points. You'll notice the curve is concave, right? Anything inside the curve. So let's look at it again. Everything inside the curve is attainable, but the A, B, and C is our maximum, our best points, right? Outside there'd be more goals. We would love that, but we can't get that. So the curve is called concave because it's an increasing opportunity cost. Unlike the pizza and brownies, which were 1 for 3 all the time, that was a straight line because the cost was constant. All right. And then the last thing we're going to look at here is what happens if we can increase the training, or we can change one of the variables, change the resources. Well, then we can have economic growth. Economic growth is shown by pushing the curve outwards, right? Where we can attain more, all right? And that's a rightward shift of the curve. All right, that's about 12 minutes. And that's it. See you in class.